Uh, Hello. Assalamualaikum and a very good morning to panel of examiner and my fellow friends. The title of my final project is the design and implementation of haptic feedback controller for robotic arm and improvement from previous project. This project is being supervised by Associate Professor Technologist, the Specialist Dr. Syed Muhammad Fairuz bin Syed Muhammad Dardin, and co-supervised by Dr. Zahiri bin Abdul Rashid. So the scope of my presentation is first come to introduction and then literature review, methodology, preliminary finding, and then with conclusion. So first let's start with the introduction. The background of this research is about in a chemical, biological, radiological, nuclear and high yield explosive, or known as CBRNE reagents, require a sample collecting to take any further action. The procedure involved in equipping protective equipment, sample collecting and contaminating require an extensive precaution and very time consuming. Robot act as intermediaries can shorten the procedure to procure the sample safely and securely by applying haptic feedback. The system will give the user a sensation of touch, pressure and weight when operating the robotic arm. Moving on to the problem statement. So the first one is the designing robotic claw with haptic control system for the operator to be able to receive feedback from the robot. Next, sensing the sample weight and determine amount of force applied, while sensing perturbation when obstruct. And lastly, servomotor issues on implementing haptic feedback. My next one is the objective. The first one is to explore techniques involved in a haptic feedback system. Second, to implement haptic feedback technique in a robotic claw. Third, to assess the effectiveness and evaluate the performance of maneuvering capability of the haptic model and its responses. The scope of work for this project is the haptic system will use force feedback through the built-in potentiometer in a shelf-ready servomotor sensors. The design and control of the haptic system will implement bilateral method of the robotic claw. The performance of the haptic system will be evaluated through potentiometer data and maneuvering capability. Second element of this presentation is literature review. So there's a few literature that define haptic feedback. First is the by Kanjana Pass that state haptic as recreate artificial stimuli for human sense of touch to enhance realism and improve human performance. Next one is by Agravi. The medium of transferring the feedback should be easily engaged in multi-contact operation and interaction with enough ability to provide effective, rich, localized and stimuli to a human user. But last one is by Bhattacharjee. Deliver haptic feedback from a unilateral setup to a bilateral setup. With this setup, the operator could map and estimate the reach of a robotic arm. Among the literature, the one by Jaswal separate the haptic field into three separate applications. First one is human, the study of human sensing and its control through touch and motion, research on construction, design, and the use of machine to substitute human interference for the machine. Last one by in computer, developing software or algorithm correlate with generating the sense of touch and motion of visual object. As far as haptic feedback concerned, there's a haptic feedback classification. The first is skin stretch feedback. This one has been published by Kanjana Pass, Agravi and by Gwinan. The feedback provides shear force to the skin through friction of fabric. Next one is pressure feedback, also by Kanjana Pass and Agravi, with the addition of by Lee, gives sensation of tighten or loosen to user by applying force in a certain area. The third one is tactile feedback, also by Kanjana Pass and Lee, in addition to Bhattacharjee. It is a transmission of pressure, temperature, or vibration on skin, a combination of three different sensations. Furthermore, temperature feedback by Tipnis, providing temperature feedback to human hand in cold or hot sensation. As far as haptic feedback concerned for this research, the force feedback by Duran and Lee is what will be applied in this project. It causes user to experience opposite force of what applied. Hardware selection. Sensor that have been published, there's a list of sensors that have been published in haptic field. So the first one is flex sensor by Jaswal, Duran, Lee and Tipnis. It is used to analyze position of operator finger depending on the flexion or bending of finger. Next one is initial measurement unit, or known as IMU, so by Jaswal and Lee and Tignis. It compute gyroscope and accelerometer, a combination, to obtain orientation or velocity of arm when moving. Next one is by is temperature sensor, specifically is LM35 by Tignis, mounted on robotic arm and effector, used to measure an object temperature. So you can see the next one is actuators. The motor can be separated into two. The one made by Lee, the one that published by Lee, is a vibration motor. It provides intense vibration feedback suited for mobile robot joystick control application. By Sankar is electric motors for positioning and power, suited for wide range of device mounted on human. The next one is air muscle, also by Sankar. Could provide high power to weight ratio. However, the air muscle actuators require a constant pressurized air supply. NTEC petroleum modules by Tignis will provide temperature feedback to human hand in a cold or hot sensation. So next I will cover implementation technique. There are three techniques that have been implemented in most of haptic feedback device. The first one is motor slave technique, a master slave technique by Box and Bay. It is about relation of robot to robot, means by a copy of robot control another robot. Next one is bilateral technique by Singh, communication between robot model and operator device. Last one is model emulator technique by Beck. Replicate the environment in a virtual world to provide instant feedback to operator, more to like VR or augmented reality, such as. So now I like to talk about the testing and evaluation in their paper. So to test the haptic feedback, so the first one by Agravi and Singh is they use a force sensitive and inevitability test. And the next one is matching capability of time and error. Third one is classification, accuracy and recognition of object by Bhattacharya. Furthermore, perturbation effect by Box and Byte. The perturbation means that it tests the deviation of the haptic system as the slave robot follow the master robot. It obstruct from the path caused by an external influence. So they check the perturbation effect. So the last one is graph detection validation by Lee. So this one is that user could comprehend the shape of object being held by. So means that the user could feel what in the claw of the robotic arm as the claw holding samples or some shape and object. So this one is challenges. So the first is the proper grounding housing the robot. Next one is time delay can cause unstable operation, especially when the system contain high degree of freedom joint of robotic arm. Fitting or fixing of device to user. Example as in to fit the device on forearm. So to gain the appropriate or maximum force being feedback to the user. And the next one is increase of response time, mostly in transmission signal. So last one is the movement threshold limit. So to prevent the apply some case that the robot have some mechanism that cannot be pushed far as a human arm could move. So there's require some mechanism to withhold the human hand from reaching the limit. So may cause some damage. So my next important element is methodology. This is the project flow and process of my project. So it starts, and then this is about the technique, is about the test review. So I separate. This one is about servo motor movement. As in hack servo motor and test haptic control between two servo. This one use method of open loop feedback and closed loop feedback, and then the hardware prototype will be made in FYP1. So hardware design of servo placement on robotic claw, implementing the control of the hardware design, test haptic between claw. And last one is identify issue on haptic response. The haptic response will be test of servo motor force feedback received, occurrence of any servo motor jittering, data mismatch and time delay of servo movement. So this is hack servo motor in servo motor movement phase. So this is the figure of hex servo motor to obtain the potentiometer reading. The internal potentiometer, there's some soldering required into the internal. So this is the circuit diagram of the servo motor, presentation of servo. Next one is open loop haptic feedback. So the figure of open loop haptic feedback, this one, circuit diagram of open loop haptic feedback. Both servo is being hacked, but both the motor is controlled by motor driver from Arduino. The one is this one is the open loop. So the user give input to the motor, and if the robot been stagnant for more than 20 milliseconds, and then the robot will give input to the user back. This one and this one. This one is closed loop haptic servo. For the circuit diagram of the closed loop haptic servo is one of the servo is still using motor driver, but another one is directly connect with the original signal of the servo signal. This is the block diagram. Just feedback. Preliminary finding. This is the demonstration. So this one is by using closed loop haptic feedback. So the data package quickly. And then this is the demonstration of perturbation effect. So they show that some perturbation occurs when being obstruct. Okay, this is the comparison of haptic feedback of the open loop haptic feedback and closed loop haptic feedback. As the response time for the open loop is longer than the closed loop. So as in conclusion, haptic feedback using open loop and closed loop have been tested for two-way movement of servo motor. A closed loop system responds faster than open loop system. The hardware design for user and robotic arm will be concerned on servo threshold limit and compatibility of multiple servo. This is the reference. Thank you for lending your ears for my presentation. That's it.
Sarah, you want to go first? Hi, Khalifa.
Hey, ma'am.
Okay, your robot is using haptic, which is the sense of the size or the sense.
Yeah.
My question is that why don't you just use a camera, to detect it rather than using haptic sense?
So in some case, the using camera does not provide enough feedback for the user, as the background of this research based on CBRNE. So some sample may be brittle or soft, and then if the user give too much of force, and may cause the sample to be harm or damage. So if using camera, so the response time for the user from grasping the sample is not fast enough to detect it.
Yeah, but using camera, you can see what type of let's say the waist or the size of it. Yeah. So.
Yes, ma'am. Perhaps the haptic feedback more to the sense of touch, more to the visual effect by camera. So if the haptic feedback can be combined with another camera or a visual effect, then both of them can be can handle the sample is more accurate.
Okay, I understand. Okay. What are the parameters that the device will detect? Is it weight? The weight of the sample?
For my project is more to force. So if the force detection been achieved, then I can move to the weight sensing.
Oh, so the main detection will be the force.
Yes, ma'am.
Okay. Hold on there. Kena?
Okay, thank you. Assalamualaikum, Khalifatullah.
Waalaikumsalam.
Okay, if I'm not mistaken, your project is a continuation from the previous project, right?
Yes, sir.
Okay, so what was the problem with the previous project and where you take on from that? If you can fill us in again.
The last one doesn't complete the robotic arm, so it end with the actually it end with this demonstration basically. So I replicate back the previous project on this on this FYP1. So next in FYP2 will be moved on the hardware design for glove, so for the operator or user, and the robotic arm that being controlled.
Okay, okay. Thank you. For my question then.
Yes, sir.
Okay, how do you foresee to have a haptic concept implemented with the open loop concept? I mean, without feedback. Do you mean when you said open loop without having a feedback loop? Is that what you mean? When you're comparing the open loop and the closed loop, right? And then
Yes, sir.
the open loop system, is it without feedback?
Actually, there's feedback but the feedback more to the unilateral technique, more to the operator control the robot, but because
You mean from visual feedback only, not from any kind of sensors? Is that it?
still using the same sensor potentiometer, but
Okay.
the feedback to the user
Mhm.
is not the actual proper feedback, because I put a delay. If the robot been delayed by 20 milliseconds, and then the operator will move to the robot position. So that one is considered as open loop, as it does not provide in real time feedback to the operator, only by if it being delayed.
Sorry, I still don't kind of understand what do you mean by delay. It's
So
because but the whoever the controller, let
yeah,
it
yes,
be
sir.
a human controller or even machine controller, it will still receive input. It will still receive some information back, or is it not?
So is it? It is, but by coding in Arduino. So as I give input to I control one of the servo as a user. The next one is move also. So this one is considered as a unilateral technique. It is not a haptic feedback concept. So I put 20 millisecond my own activation or more, so that if the robot cannot move to the position being input by user, so the robot become the input to the user back.
Okay, okay. I don't know whether we can qualify that as a open loop, but it's okay. It's okay. I see what you mean. So the concept is not an immediate feedback on the haptic sense. Okay.
Yes, sir.
Okay. Okay. Thank you. That is all from me.
Yes, sir.
Okay, thank you, Khalifadullah, for a nice presentation. No question from me. So can the next person proceed?
Thank you, ma'am.